Gandang araw po sa inyong lahat sa seryeng ito ng Pisiko-Matematiko. Pag-aaralan natin ang scientific notation, significant figures at least count of a measuring device. When we are dealing with numbers, sometimes you will see numbers like this, 1 light year, meaning the distance traveled by light in 1 year, the speed of light in vacuum, or a very small number tulad ng angstrom size or nanosecond, mass of an atom, or charge of an electron. So these are very small and very large numbers, which when you take them as is, there will be some issues on computation errors or confusion. So we write it this way. We call this a scientific method of writing numbers or scientific notation. So it follows the form n times 10 to the exponent y. N is a decimal number between 1 and 10, and y is an integer exponent of the base 10. If the numbers, or if the given number is greater than 1, generally the exponent of base 10 is positive. If the number is less than 1, the exponent of base 10 is negative. However, you can also generate an equivalent positive or negative exponent by moving the decimal point to the left or right of the decimal point. So to express n, move the decimal point in such a way that the number n is between 1 and 10. If there is no decimal point, the implied decimal point is always at the last character of the number. So in this case, 0. So in here is 9.65, and you need to count or move the decimal point that is the equivalent exponent. So when you move the decimal point 8 times to the left, you'll obtain 9.65, and exponent is also positive 8. So generally, moving the decimal point to the left gives positive exponent, and to the right gives negative exponent. So in this case, you move the decimal point 4 times and obtain 1.73 times 10 to the negative 4. The numbers 100,000, 135 billion, 0.00125 are called standard decimal forms. And when we write it in scientific form, we obtain ABC. Try this writing the standard decimal numbers into its scientific form, and letter B, convert the standard decimal numbers given the scientific notation. You can pause the video, and then after which you can compare your answer. We have arithmetic in scientific notation. First, we have multiplication and division. In multiplication and division, we apply the laws of exponent. Example 1, 2.1 times 10 to the 7th power multiplied by 3 times 10 to the 3rd power. So we multiply 2.1 by 3, and then we write the base 10 and add exponents. So you have 6.3 times 10 to the positive 10. In example 2, we use the same procedure, and in example 3, we write all the items in scientific notation, and then we come up with the final answer. In addition and subtraction, you have to rewrite or express the numbers in the same power of 10. As shown in example 1, 3 times 10 to the 5th power plus 2.5 times 10 to the 6th power. So they have different exponents. You can write the bigger one or the smaller exponent depending upon the given numbers. Example, in 2.5 times 10 to the 6th power, we can rewrite it into 25 times 10 to the 5th power. And then we can proceed to addition. So that will be 3 plus 25. Then we just use 10 to the 5th power as the base and power. Rewrite the final answer. That will be 2.8 times 10 to the 6th power. We did the same for example number 2. Now try to practice here. Use scientific notations without using calculator. Then express all answers scientifically. You can pause the video and then try to find the answer here. If you're done, you can proceed and compare your answers. Normally, the final answers for n are rounded off. Okay. The next topic is about significant figure. A significant digit or figure is the degree of certainty of an approximate value. So in this case, 4.5 centimeter, the approximate number here is 5. The value 4.5 centimeter has two significant digits. Generally, we have this rule in writing the significant figures in measurement. To add or subtract the significant figures, the last digit of every number is uncertain. So add or subtract in the normal fashion. Then round the answer to the least number of places to the decimal point of any number in the problem. So in the example, we have 0.33 is the least number of decimal places, decimal points. So the final answer must have also two decimal, two numbers after the decimal point. Just like in the difference between 987.26 meters minus 74.2 meters. So we just retain one decimal number, one decimal point. In multiplication division, the product or quotient must have the least significant figure. So in this example, x50, two significant digits, 38, two significant digits. So if the final answer is 24,700, round it up to 25,000 because the product should have only two significant figures. Likewise, in 1.53 multiplied by 25.64. So we have three significant, less significant number. So 1.53 has 3, so final answer will be 39.2. In division, we do the same. Please pause the video if you want to do this, do the practice and perform the indicated operations. So if you did it, you can compare your answer with our answer in the next slide. Another topic is about the type of tools or equipment we use in physics. We have analog and digital. In digital tools, if we calibrate that to 0.0, then the digital tool will work just as fine. However, for analog devices, like the other examples here, you need to find the least count of that equipment. The least count is the minimum measurement that can be made by a measuring device, like an analog device or equipment. Generally, the least count is minimum measurement on the main scale of the device divided by the total number of deviations of that scale. For example, this weighing scale, if you are going to look at the numbers, the first visible number from 0 is 20, and there are 4 divisions. So do not count 0. The LC will be 20 per first visible number divided by 4 divisions. You have 5, meaning the least count is 5 kilogram. That is equivalent to 1 line. And that is the minimum measurement that can be taken by this device. So we have here a centimeter scale. If you look at it, what is the least count of this scale? The minimum number in this scale is 1. From 0 to 1 there are 10 small divisions, so least count is 1 centimeter divided by 10 divisions, 0.1, meaning the minimum value that the device can obtain in measuring length is 0.1 centimeter. More tools like screw gauge or vernier caliper will give us a fine measurement. So this will be our next topic. Okay po, maraming salamat ulit. Please support my science channel, Fisico Matematico. Huwag po kalimutan mag-subscribe, like, and share. Next topic po ay using vernier caliper and micrometer or screw gauge. Thank you so much. I hope everyone is safe. Stay safe always.